So this video is covering the second half of the giant solving linear systems assignment that I have given you. You might want to download the linear system type notes because that'll really help you on this. What I'm going to say about this, there's that goofy ad that keeps popping up. What I'm going to say about this is study this document because most of the systems on this assignment are of type 1, type 2, or type 4. I don't think there's any of type 5 on there. And about 2 or 3 problems of type 3. So 1, 2, and 4. Linear type 1, you have 2 sets of 3 corresponded values. Okay, so 4 calls, 20 text messages cost $4. 10 calls and 5 text messages cost $5.50. That is a trigger to write a system like this. Okay, using X and Y. I'm going to use X and Y all the time and then just refer it back. There's also the type where you have one set of 3 corresponded values, so like the dollar values in this, and then a total line. Okay, and you see the 2 types here with the money and with the tickets. And then you have the legendary X plus Y, X minus Y systems, which I did one with the time upstream, downstream type of problem that you will see in this. So I've selected a few problems to do, and you need to know that you can use the app or the online app to solve these. I don't care how you solve them. It's just I want the focus to be on setting them up correctly. So here we go. You just need to focus on what type. So this first type is an X plus Y, X minus Y system, which by the way on those you should always do by hand. So the sum of 2 numbers is 12 and their difference is 4. What are the 2 numbers? So because this system is like already ready to go, you can just add it. So 8 and 4 are your 2 numbers. Let's put the 8 back in and you'll see. Number 4, you see these 2 sets of corresponded values. And this is going to happen a lot. And so you just want to make sure that you get it written correctly. And then 3x plus 2y is 52. And then go and use an app and solve this, knowing that x represents the price of a senior citizen ticket and y the price of a child's ticket. So focus on the setup. That's what I want you to do. So 814 is the solution to this system. And you need to, all of these systems are going to have a solution, so you need to write it as a coordinate. I definitely need to see that. So problem 6 is one of these problems like this here. Ends up being an X plus Y, X minus Y system, where the X plus Y represents going like with the current or with the wind. And so X is the speed of the plane or the boat, and Y is the speed of the current or the wind. And then you need to figure the speeds out on the right. So the problem is they give you the distance and the time. So if you take 200 and divide by 10, you get 21 miles per hour going downstream. And then it's going to be even less coming back to 10 over 70 hours. So that means you're going slower because the current is stopping you, slowing you down. So add them together. 2x is 24 and x is 12. And then y would be 9. So 12 is the speed of the boat and 9 is the speed of the current in miles per hour. Okay, many, many more to go. You just need to focus on what type are you looking at. Okay, I see two sets of three corresponded values again. So that makes life pretty easy. Just make sure that you're corresponding things correctly. And 11x plus 11y is 220. And then solve for x and y, and you get 7 and 13. So $7 is the cost of a box of oranges, and then 13 is the cost of a box of small and large. Sorry, small. $7 is the cost of the small box. 13 is the cost of a large box of oranges. Okay, 11 is another problem where you have this going with the current and against it. So you need to divide again. So 336 over 12 gives you 28. And then 336 over 14 gives you 24. So the 28 again is with the current, the 24 is going against. So speed of the boat and then speed of the current are the x and the y. You solve this. So x is 26 and then y is going to be 2. So 26 miles per hour and 2 miles per hour is the current. Okay, many more to go. These problems are going to be, these money problems are going to be of type 2. So you have a set of corresponded values, 3 are corresponded, and then one value is the sum of variables. So what does that mean? So a collection of dimes and quarters is worth $4.25. So let x be the number of quarters, let y be the number of dimes, and then this is your money line. There are 23 coins in all, so that is the sum line. And now you need to solve that system, which again, I don't care. You can use technology to do it because it would take you forever to do all of these by hand. And you get 13 and 10 as the solution to that system. So type 2, all of these problems in this section are of type 2 when you do them. Taking us to this next section. So as I will tell you again, almost all of the problems you do will be of type 1, 2, or 4. Okay, with this. And so on problem 3, this is going to be a type 2 again. Okay, where you see these 3 corresponded values, legs, legs, and legs. So however you want to write this, for x plus 2y is 128. So x is the number of cows and y is the number of ducks. And a total of 52 animals on the farm. Okay, so 12 and 40 is the solution. Pretty simple. What you should try to do is read through it and first of all figure out the type that you're talking about. So Alice bought 3 burgers and 5 fries for a total of $27.50. Oh, very interesting here. So you notice the 3 corresponded values, 3 burgers and 5 fries for $27.50. This is a type 3 system. So what a type 3 system is one variable is defined in terms of something happening to the other variable. Okay, so a hamburger, which I let the x be, cost twice as much as the fries do. Okay, so to get them to be equal, you would have to do this. So like if the hamburger costs $5, the fries would cost $2.50, but you're trying to make them equal. So it's 2 times the cost of the fry value equals the hamburger value. And if you're going to use the app, you got to subtract the 2y over. But in this particular problem, you get 5, oh, I guessed it, and 250 for the solution. So the rare moment of a type 3 type of problem there. Problem 7 is the 2 sets of 3 corresponded values. Again, 2 adult tickets and 4 youth tickets cost $58. 4 adult tickets and 5 youth tickets cost $90.50. Okay, what is the solution? 12 and $8.50 is that. The 2 sets of 3 corresponded values is very, very simple. Simple problems to do. Okay, so 2, 3, and 4 on this kind of gives us one of each. 2 is the 2 sets of 3 corresponded values. So it's almost like a left to right thing. You just need to make sure that you've got all of your values right and they haven't switched something around on you. Okay, so $14.98. This is definitely an app in 1985. So when you run that through, the app will do anything as long as you set it up right. Just remember to hit the decimal so that you can see it. Okay, so this is type 2, where you have the 3 sets of corresponded values and 6% annual interest, and that is 8,600. I must have changed. So I had to just pause for a moment and make sure this was right, and indeed it is. And then you have the total line of 10,000. And then you solve and you get 7,000 at the 5% and 3,000 at the 6%. Okay, 4 is the sum and difference game again. Sum is 12, the difference is 4. What are the 2 numbers? I think this is exactly the first problem, so 8 and 4. So these end up being pretty simple. If you can use technology with them, just try to focus on the set of notes. So all of these are of type 2. It looks like there's a couple in here. Actually, one that's of type 3. So what I mean by that is you have the 3 corresponded values is 100 points, and then each problem is worth 5 or 2 points. So you look for, in the problem, the things that are common. So 5 points, 2 points, and 100 points all go in one line. And then there's some type of value that represents the sum. So when you see 4 values, that's a type 2. When you see 6 values, that's a type 1. Oops. Type 2 and a type 1. So 4 values versus 6 values. And then your type 3 is a comparison back and forth between variables, and you have 3 values representing 1. And then you have the x plus y, x minus y type of systems. There's type 5, but I rarely see them. So the solution here is 830. Again, you can use technology to figure these out. So 6's, I don't know why I picked 2 of these to do exactly the same thing. You have 3 corresponded values, and then you have a 4th value that represents the total. So 3, 2. This here, number 3, is a type 3. And it's interesting. I'm going to do some of these at the end here. If you can actually think about it and figure it out. Okay, 7, another type 2 with the money. Dimes and quarters, so however you want to figure this out. So you got to have the money line, all the money values together, and then 13 coins in all. So 8 and 5 is the solution. 8 quarters, 5 dimes. On the back of this, let's do a couple of problems where, okay, these are interesting. Nickels and dimes. So we have these 3 that go together, nickels and dimes for the total. She has 3 times as many dimes as nickels. So is that going to be this or this? And that's the big question. So this is a type 3 system. So we got to make them equal. So if she has 3 times as many dimes as nickels, so let's say she had 9 dimes, that means she has 3 nickels. That won't work on this one, but it will work on the second one. If she has 9 for y and 3 for x, that'll work. So it's y equals 3x. So what I'm doing is I'm just using a set of values, not the answer, but a set of values, and substituting them in to see which one it is. So again, I used 9 dimes and 3 nickels. So 9 is y, and 3 would be x, and so the second one is true. Same thing on 15. And this will be the last one that I do. He has 150 coins, all in nickels and dimes. So we have this. Actually, that's this, because that's a total. He has 12 more dimes than nickels. So is it this or is it this? So you have to think about the dimes is y. That's what I want it to be. Nickels and dimes. He has 12 more dimes than nickels, so let's say 22 and 10. He's got 22 dimes and 10 nickels. So it's looking like that it's got to be the x, because I made the y equal to dimes. And I guess it doesn't matter. So I made the nickels x, so you've got to add 12 to the nickels to get it equal to the dimes. So sometimes it's a little bit tricky. So how many dimes does he have? So it's going to be 81. And then the nickels would be whatever 150 minus 81 is, 69. Yeah. And 69 plus 12 is 81. So it just depends on what you, sometimes you got to think a little bit about it. Depends on what you are setting up for x and y to get the right thing, but you do need to definitely identify the variables. All right, so that's your second part of this. You need to um, do all of them, and you can use technology to get the answer. That is okay.